The last implementation of spanning tree protocol I want to cover is called MST, or Multiple Spanning Tree Protocol. In Cisco implementation, it runs over rapid spanning tree, but configuration-wise, it's a little bit different and more involved. The reason being, we form between the switches something called a region. So if the configuration parameters match, I'll show you in a second what those are, they form a region, and it is also backward compatible. So for example, if I had a region in MST between switch 1, 2, and 3, and switch 4 would be a legacy one, this would be seeing the region as one ginormous bridge. So for example, if there's two connections to that region, one will be the root port and the other will be still alternate. Nothing changes here. Configuration wise, I prepared already a quick configuration. We start with the global config mode with this command, spanning tree MST configuration, and the parameters the switches in the region in MST have to agree on are the following: the name, it's case sensitive, the revision number in MST configuration, and instances. For that purpose, I've created VLANs 1 through 10. Actually, 1 is the default, so I added 2 through 10 on every single switch in my topology. And this configuration must be identical on all switches in order for them to form the region, the common region. Upon doing that, we exit out from this configuration, we enable the MST flavor in a global config mode, and that's the way it's done. So basically, if I have this prior configuration in my text editor, I can go back here and just basically paste it in and enable this on all devices here in my network. So upon doing this configuration, they form the same common region because they have the same configuration in MST. If I were to now add, let's say, root bridge manually, because this is what I want to do, the root bridge is going to be primary for VLAN 1 through 10, instance 1, it's going to be switch 1. It'll be secondary root bridge in case of a failure of the primary for VLAN 6 through 10, which is instance 2. And the opposite is going to be done on switch 2. This is going to be root primary for instance 2, VLANs 6 through 10, and secondary for VLANs 1 through 5, which is the instance 1 in my configuration. So to do that, it's quite simple. I'll say here on switch 1, spanning tree MST instance 1 root primary, and for instance 2 I'll be secondary, and I'll do the exact opposite on switch 2. So spanning tree for instance 1, it's going to be root secondary MST, and for instance 2, I'll be primary here. That's it. Now the configuration wise, that's what it's done. A few maybe show commands, show spanning tree MST. And if I do that, just maybe configuration first. This shows me the mapping between instance number and what VLANs belong to the instance. Now, you may have noticed that there's an instance 0 here. That's a common inter-spanning tree flavor. What it does, basically, it maps all the remaining VLANs to instance 0 for the legacy communication purposes. So if there's other regions which have the same VLANs, maybe we'll be communicating with them using the instance 0. The same with the legacy switches. The instance 0 is used to communicate, so we can send all the BPDUs for all the VLANs if necessary. Now, show spanning tree MST question mark. We can go for detail, we can go for particular instance, for example, and maybe just this instance display. We can go for detail output. It shows me who the root is. This is the root for MST1, and this is the address. So if I do the same command on switch 2, show spanning tree MST1, I will see that bridge. This is the ID of switch 2, and this is still the root bridge for that particular instance, and it'll be opposite for obviously instance 2. Also, what is worth mentioning is that the cost of each port, it changes. It's more granular, allowing a better computation for higher bandwidth on the interfaces. Other than that, it behaves pretty much the same. So it saves on BPDUs because now we're sending two BPDUs, one per instance 1 and one per instance 2. So the computation is probably less heavy on those switches. So that concludes spanning tree configurations. In the next video, I'm going to cover the basics of OSPF, and we're going to go really deep with that protocol and the features it offers.